In this presentation, we are going to take a look at how we can perform regression analysis. A regression analysis is a method that we tend to use to examine linear relationship between two numerical data. An example of which we have here. We have stress level, which is measured in numerical values from 0 to 100, and level of productivity, which is also measured in numerical values from 0 to 1. So the question is there any linear relationship between employees' stress level and their level of productivity? So we need to explore what is the nature of the relationship between a person's stress level and their level of productivity. That is, how does stress level impact a person's ability to be productive? So there are a couple of questions that we have to respond to when answering these questions. So before we begin answering the questions, we need to explore how Excel performs a regression analysis. To do this, we go to Data, select Data Analysis, and pick Regression. In Regression, in the dialog box, you are asked to identify the input for the Y range. The Y range here given in the question is work productivity. So that means this column here represents our Y range, the Y values, productivity. So we need to select these values in this input box. So we place our cursor right inside the box and then select the data, including the label header. And then we do the same for the input X range. Our X range here is our stress level, which is basically the independent variable. So we select that for the X range. So we have the relationship between independent variable and a dependent variable. We need to explore what is the nature of the relationship and how do we predict the dependent variable based on our knowledge of the independent variable. Now from here we have to make sure we check on the labels because we actually included the labels in our selection. And then we need to indicate where we would like to input the results. So as the cursor blinks in that box, I'm going to select any blank spot to place my results in, and that is it. So I click on OK, and I should have my result output. So just expand on the cell, hold and drag, hold down the cursor and drag just to expand, just to see the numbers. It gives you a lot of information right here, but we are only going to concentrate on few of them. So the first question being asked is question A. Interpret the coefficient of correlation and determination. The value here, this value represents your correlation coefficient. So that's the correlation. So the correlation is 0.7823. 0.66. So run it to the 4 decimal places. So in that case, this indicates a strong relationship. And then our coefficient of determination, which is question A. So there are two parts to question A, the correlation coefficient and then the coefficient of determination. This is our R square represent our determination. So the multiple R gives you your correlation, the R square gives you your determination. Now, the correlation given here only speaks to the strength of the relationship. It only speaks to the strength. So in order to obtain the direction, we need to take a look at the direction of the slope. So we need to look at the slope direction, and the slope direction is given by this value. So the value negative 0.73 is the direction of the slope, and you notice that it is a negative direction. So if the slope is heading towards negative way, then that means our correlation should also assume such a negative direction. So for that reason, our complete interpretation of our correlation coefficient is going to be negative 0.7823. So let's take a look at the interpretation. The correlation coefficient is negative 0.7824. This means there is a strong negative relationship between stress level and work productivity. Thus, an increase in stress level is strongly related to a decrease in work productivity. Now let's take a look at the coefficient of determination. The coefficient of determination is given as 0.612097. So to 4 decimal places, that takes you to the coefficient of determination is 0.6121. This means 61.21% of a person's work productivity is determined by his or her stress level. Now, coefficient of determination is sort of transformed into percentage by multiplying the value that we have here by 100, and that should take you to a percentage of 61.21%. So that means what proportion of your dependent variable is influenced or is determined or explained by your independent variable. In this case, 61.21% of my work productivity, which represent my dependent variable, is determined by my stress level, which is my independent variable. So that is the interpretation that we give to coefficient of determination. The next question asks for interpret the Y-intercept. The Y-intercept is given as this value. Our Y-intercept, which is stated as intercept, is 88.76899. Right, so we run into 2 decimals, so that should be 88.77. So the interpretation of the Y-intercept is given as the Y-intercept is 88.77. This means a person with 0 stress level is expected to have a productivity level of 88.77. So that is the interpretation assigned to Y-intercept. A Y-intercept looks at if X is 0, if your independent variable is 0, what is the value of your dependent variable, your dependent variable being Y. So that is essentially what the Y-intercept explains. Then question C asks for interpret the slope of the regression line. And the slope of the regression line is given as your stress level, which is mentioned right here, which is negative 0.732369. So let's take a look at the interpretation of that, what that means. The slope of a regression line is negative 0.732. This means an increase in stress level by 1 unit will lead to a decrease in productivity by 0.732. So that's essentially what slope represents. Okay, it means that when y increase by 1 unit, what is the response by the y variable? So when when x increase by 1, how does y respond, right? So in this case, my x, which represent the independent variable, when it increased by 1 unit, which is the stress level increase by 1 unit, my dependent variable, which is represented by y, will decrease by 0.732. It will decrease because of the negative sign. It has negative to it. If this were to have a positive value, if the slope were to have a positive value, that means that instead of a decrease, it will have been what? An increase. So that is the interpretation assigned to a regression, slope of a regression line. The next question asks for state the regression equation and predict the work productivity of an employee with a stress level of 85. So the D part of this question is asking you to do a prediction. So we're going to state the regression equation, or the model, or the simple linear regression model, which is your equation, and use the equation to make a prediction. So the equation is going to be y equals the Y-intercept, which is given as 8.77, plus the B slope, the slope of our regression line, which is given as negative 0.732 times x. So that our regression equation is clearly stated as this: 8.77 plus into bracket negative 0.732 times x. Given this regression equation, or simple regression model, can we predict our y, or can we predict our level of productivity when our stress level, or when stress level is 85? Yes, we could do that. All that we need to do is, in order to predict y and x is 85, we just substitute 85 into the equation, and you note that 85 represents our x, which is our independent variable, that is substituted in the equation, and the equation will look like 88.77 plus into bracket negative 0.732 times 85. So this is the full equation, and with placing all the numbers, and now we can work out the calculations. And when you work out the calculation, you should end up with 26.55. So what that means is an employee with a stress level of 85 is expected, or is predicted, to have a productivity level of 26.55. Then the last question asks, actually not the last, the E question asks for interpret the standard error. The standard error is given as, this is our standard error of the estimate, which is 14.28753. Now to 2 decimal places, That takes you to 14.29. So if we take these to two decimal places, we have it as 14.29. So the standard error of the estimate is 14.29. And what does that mean? It means the predicted productivity level, the prediction that we did here, the predicted productivity level will typically differ from the actual level by 14.29. That is to say that although we've made a prediction, our prediction will not be exact. We may have to give it a margin of error, right? We make a prediction to something that is unknown. It's always good to vary it so that it will give you some margin of error to which you can identify a range in your predictions. So the standard error is basically your standard deviation, which gives you the give and take around the predicted value upon which you can therefore provide a predictive estimation, or an estimation given a range of values. Okay, so in this case, our standard error of the estimate of 14.29 means that the predicted productivity level is expected to differ from the actual level by 14.29, give and take, and that is in essence what standard error represents. Now the last question here is, at alpha 5%, test the significance of the linear relationship between stress level and work productivity. So here, this is where we want to make a determination whether the relationship is statistically significant. We need to come out with that conclusion. Yes, we were able to speak to the fact that there's a strong relationship as given by the correlation coefficient, but we also need to speak to the fact that whether the relationship is statistically significant, right? And to test for this, we then have to use the F test to come out with that decision. The table here gives you that knowledge. Now this is the F value. This is the F test value. And then we need to compare the F test value with a F critical value, right? So there's two ways by which we can test this hypothesis using a critical value approach. The critical value approach requires that we compare the test value, which is given as 44.18, with a critical value from the F table. Now, to read the critical value from the F table, we need to look at a degree of freedom for the numerator to be 1, which is the degree of freedom for between to be 1, and the degree of freedom for within to be 28. So we need to look at the critical value table and read the degree of freedom of 1 for the numerator and degree of freedom of 28 for the denominator, which is within degree of freedom and between degree of freedom. Okay, so in doing so, we will be able to come out with a critical value. So the critical value for between of 1 with degree of freedom for within of 28 should give you a critical value of 4.196. So with a critical value of 4.196, if you read this from the table, you should identify this easily. It gives you the critical value will be 4.196. Given that, you compare that with your test value of 44.18. And since the test value is greater than the critical value, we will conclude that the linear relationship between work productivity and the stress level is statistically significant. As we always allude to when we're doing hypothesis testing, when you're dealing with F right tail test and your test value is greater than your critical value, the decision will be to reject the null and conclude that there is a statistically significant relationship. And that is the same concept that we are applying in this case. So as a result of that, we are going to conclude that a linear relationship between work productivity and stress level is statistically significant because the test value is greater than the critical value. This is even further supported by the p-value. So let's take a look at the p-value. If you want to take this is your p-value. So the p-value is here is given as 3.26917, and then you notice an exponent. There's an e, which represents an exponent negative 0.7. What that means is you need to move the decimal place 7 times to the front, and then you end up with 0.000003269, and that is what it means. It's a scientific notation. So in that case, our p-value will end up being 0.000032, right? This is multiplied by 100 to transform this into percentage, so we end up with 0.00032, which is less than the significant level of 5%. So again, when a p-value is less than the significant level, it gives you a reason to conclude that there is a statistically significant relationship between your dependent variable and the independent variable. In that case, the interpretation is that we have a very small chance of making an error in our decision, because this is the error in our decision, is to reject the null, we err by 0.000032%. This is minuscule, very, very tiny error. So it means that our decision to reject the null is solid and valid statistically, and that basically concludes the analysis of regression for this particular question.